Hello and welcome back. Today I want to talk about the Linux file system hierarchy. Let me pull up my diagram that I got from the Linux Foundation, and I just want to show you the geography of the Linux file system and how it contrasts with the Windows file system architecture. And let me just show you or just mention a few basic facts about the Linux file system. So a computer will have one or more devices that are used to store data called disks. Let me go to VirtualBox, the VirtualBox Manager actually, and with server 1 highlighted, I'm going to click on storage, and then under the SATA controller you can see we have this .vdi file as our disk. So that's okay. And then what you can do is separate your disk into partitions. So to demonstrate this, the disk that we are working with is system disk A, and we have partitions. Here's the boot partition, SDA1, and then the partition that the root file system is mounted to is SDA2, and then this is the CD, DVD, ROM drive you see here. So partitions are sections of a disk that are treated as separate storage devices, and then file systems can be created onto the partitions so that the partitions can store files. That's very important. So let me move on. So most programs will only work on partitions that contain file systems, and then this is how we would define a file system, by the methods and data structures that the operating system uses to store files on a disk. So let me demonstrate something about inode numbers. I'm going to clear the screen, and I'm going to use the touch command that will change file timestamps, but it will also create files. So I'm creating file 1 through 4. And now I'm going to use ls long listing and then inode options to display the inode numbers. And then an inode is a data structure that stores file attributes and disk block locations for the file's data. And these file system attributes are metadata that describe, and I have some examples. For example, the time of last modification, and the files have one link here, but the directories that have no files in them, for example, or I kind of just see there are no, and that is because we have a link to the current directory and we have a link to the parent directory. So if I used ls-a on videos, you could see these two symbols here, and that is why when I change directories into this directory, I could just use change directory and then ... So I want to change directory into my parent directory, and then here I am. So I'm just going to clear the screen actually, and I'll have more on that later. So Windows has a hierarchical structure in which the programs themselves manage the file system, e.g. Program directories, but not the operating system. So I have here an example of the file path under the C drive where you will find the program files, and that's why on a Windows system you can put your files on the C drive, E drive, or whatever. But in contrast, all directories in Linux are subdirectories of the root directory. So just really quick, I want to contrast the root directory from the root user's home directory, because the actual program files should never be in the root user's home directory. In fact, that should be only files that are for the administrator. So the root directory is the parent directory for all of the subdirectories, and they are arranged by their importance to the boot process. And so a file system must be mounted for it to be accessible by the system, and they must be unmounted when the system is shut down so that the file integrity can be maintained. And that's very important, to use the proper shutdown command before you shut down your system, rather than cutting off the power unexpectedly. Let me move on a little bit. Let me show you, and I will cover this in greater detail when I go over when I go to chapter 4, and then I will go over exactly how to add disks, and then make partitions, and then make file systems, and then the particulars and how to mount and unmount. But let me show you, let me go to full screen here, what is mounted on our system at the present time. Okay, I'm just going to quit, and then I'm going to use ls and then all, so to show the dot and the dot links, symbols, and then long listing, and then human readable, so that when the size is displayed, it is in a shorter format. And then long listing, so I can see the permission blocks, for example. And so the root directory is the parent directory, and then all other directories are the child directories of the root directory. So let me just get lined up here. The first directory I want to talk about is the bin directory, and in there you will find the essential command binaries. So it is a symbolic link to Unix system resources bin subdirectory. And so a symbolic link is just a file that refers to another file. So when I list these two directories out, they have the same files. And so in this directory you will find shell applications such as bash. So moving on to the next stop, the boot directory. And very interesting, and it contains the grand unified bootloader that loads the operating system, and there is its configuration file. And so the initramfs files, their purpose is to mount the root file system. And then you have the symverse files and the system.map files. So the symverse files have a list of all exported symbols from a kernel build, and then the system.map files contain symbol information for a compiled kernel, while the VM Linus files, those are the kernel files. And let me show you something. The uname command will print system information, so I wonder if I remember this. There. So the kernel release we are currently using is this one, 15.2. And that is the main application that is the interface between processes and hardware. So for example, the bash process is what I'm using currently to access the hardware on this system. Okay, I'm going to clear the screen. And next stop is the dev directory. And this is fascinating. This has all of our device files. And remember, everything on the Linux is a file. And so you can see the partitions here. And if I use the who command, I know that dev pts 0, so let me so you can see pts 0 has been created for this PuTTY session here. So that is our sudo terminal device file. And let's just look for dev cd-rom, and let me actually do a long listing here. Okay, and so it is a symbolic link to sr0. And so at the sr0 file is the representative for the CD DVD ROM drive. Meanwhile, dev null will discard data that is sent to it. So I often will send error messages to dev null so that they will be disposed of. While also dev 0, in contrast, will provide as many zeros as are read from it and is useful for erasing data. So that's interesting to remember. I have memorized these two files because I often send data I want disposed of to dev null, but if I also have data that needs to be erased, I use dev 0. I'm going to clear the screen, and I have listed the etc file before. This is where you will find your system configuration files. It's a good idea to back up this directory, but it's just a catch-all directory for all of your config files. And so the home directory has hidden files as specified by the dot in front of the file, and I will cover this specifically in chapter 3 when we talk about user provision and user home files and creating them. But moving on, let's talk about library files. So library files are files that allow multiple applications to they're repositories of code that allow multiple applications to access them simultaneously, so that you don't have to have replicated code on your system. So let me just show you where they're at, and you can see that's a symbolic link to usrlib. And then this is for your 64-bit applications. So shared library images that are needed by binary files in bin and sbin to run commands on the root file system. So in short, these applications need these shared library files to function. And so they're identifiable by their .so suffix. And a Windows equivalent would be the DLL, dynamically linked library file. And of course, they're essential for basic system functionality. And I will cover these in greater detail in chapter 2. I'm going to press quit. Then I'm going to clear the screen. And currently we don't have a removable media drive installed. So the mount directory is the mount point for a temporary mount. So it's empty. But what I'm going to do now is I'm going to go to my VirtualBox Manager, and then I'm going to go to Storage with Server 1 highlighted. And then I'm going to go to the DVD-ROM drive. I'm going to select a DVD-ROM. I'm going to press OK. So now it's loaded in there. Okay, so now I'm going to use the mount command. What is mount? That will mount a file system. Okay, so I'm going to mount this file to the mount directory. Okay, now it's write protected, read only. Okay, so if I want to unmount it and make it unavailable, I'll use this command. And of course, it's restricted to the root user, as it should be. And now it's empty. So just a really short proof of the concept of this directory here, and you'll be using this extensively, especially if you don't want to mount it to your basic file system. You can just mount it to that directory and then unmount it very quickly. There's nothing in the op directory actually. Okay, let's move on, and let's take a look at the process directory, the proc directory. We'll have our processes here, and these are pseudo files, and they contain runtime sensitive information, system memory, and such. And the kernel will use the proc directory to obtain information about and control system processes. For example, later on we will use the lsmod command to format the information in the proc modules directory to show the status of modules in the Linux kernel. But something that we have right here is the sysctl command. So that will configure kernel parameters at runtime. So it alters files in the proc sys directory to modify kernel parameters at runtime. So let's take a look at the proc sys directory. Okay, you can see the directories there. I'm going to clear the screen. And so I'm going to cat the specific file. So cat procsys, and then net, and then IP version 4, and then IP forward, and then the value is 0. So what I can do is enable this. What this is IP version 4 forwarding, or routing. So if I wanted to make this system into a router, I would have to change that 0 to a 1. So let me show you how to do that, and we'll use the W. So okay, so that is the write option, which will enable writing a value to a variable. So and then what comes after that is very odd, because what I'm doing, I'm assuming this directory is what I'm working on, because sysctl exclusively works with this directory here. And then I'm taking the path and then I'm writing it as it should be, but I'm using the dots to separate the path. I'm using the dots instead of the /, really, and then I'm specifying 1. So let me run that as root. Okay, and so now you have that. When I cut it out, it says 1. And now, just in the same way, I will disable this. I'm just going to clear the screen. And I will use this again in our curriculum. I just wanted to show a very short proof of concept. So here we have the number directories here, and they correspond to the process idea of a process. And so I will cover processes in great detail in chapter 2. But let's just take a look at the map. And so we were just in the proc directory here. And so the next stop is the root user's home directory. Okay, and nothing much to see here because I don't do much as the root user except for run the installation bash script or shell script actually. So let me just clear the screen. And so the run directory, well, that's what I get for forgetting less here. The run directory contains system data that describes the system since it was booted. And they're cleared upon system boot, it says here. But we will go back to that directory when we can. I think perhaps in chapter 2. So the sbin directory is symbolically linked to the usr sbin directory. And you can see all of the applications we have here. The way that this differs from the bin directory is that it contains binaries that are not normally executed, so not normally executed by non-privileged users. So let me just quit out of this. Let me use this list command here. So you can see we have these two commands here in this directory. And so my point is that a non-privileged user should not be able to shut down the system or update passwords in batch mode the way that chpassword will do. So that's good to know. And so it's here on the map, sbin, but of course it's symbolically linked to the usr directory. And then there's where bin is symbolically linked to. So let me move on here to, there's nothing here usually. So I just wanted to include it actually. And then the temp directory contains temporary files for applications. And here's an interesting thing, is that something called the sticky bit is enabled on this directory to prevent people from changing or renaming files in this directory. Because if you have multiple users on your computer, you will have multiple people putting things in the temp directory. So, and I will cover the permissions for the Linux system in a later episode, but I just wanted to point that out. I'm going to clear the screen, and so let us move on to the usr directory. It's right here, and you can see it's very, very large. And I like to remember it as the Unix system resources. So fdisk is found here. So that's an SBIN because it manipulates the disk partition table. Okay, so essential system binaries, they're not normally executed by privileged users. And so we have shared libraries and kernel modules. Let me just change this. So lib64 contains 64-bit libraries. So let me quit out of this, and then next stop, you have your header files as designated by the .h suffix. And these files are needed for compiling user space source code. And so the source directory contains the source code for the most current kernel. And I'm sure this is going to fail. Is this going to fail? But then again, I mean, I still have that kernel actually. But let me change this to reflect the current kernel. Okay, I mean, it looks the same, but you know. Let me clear the screen. All right, so self-compiled or third-party software is installed locally in this directory. That's empty. And then USR share stores data for applications that do not need to be modified. And so you have configuration files and scripts that are used by applications. And this will be useful if you are installing an application and you want to know where it's where the configuration, the sample configuration files are. And later on, we will install Open a VPN, and I will show you how this works. So let me just quit here and run this command here. And so the USR share man is where man pages are located. So that's interesting. And then if you wanted to know where the info pages were located, here they are, and they're gzipped so that they don't take up so much space. And then finally, USR share doc is where package specific documentation, templates, and configurations are found. So another place to look for if you need a configuration file. And this is pretty massive actually. You can see how many of these are directories containing those files that I was talking about. Let me just quit and move on. So just to review, we have bin, and then include, and then lib, local, and then we got man pages, and then your configuration pages for your applications that you have installed. So let us move on to the var directory. So you have var, and then you have lib, and then you have run, log, spool. Let me just explain what those do. And the var directory contains files and directories that may be written to during operation. So, for example, log files. Whereas the USR directory only contains static data. So, going back to the map here, so USR, this never changes really, unless you install new applications and something is added to USR share doc. It doesn't really change much. But the var file, the files in the var directory do change, especially if when you're thinking about a log file. Of course, more log files are added all the time. So var cache contains cache data from applications and is cached to prevent time-consuming input-output or calculations to be performed repeatedly. For example, var cache yum contains cached software packages that were downloaded, installed, or removed. And now I'm just going down a rabbit hole, but I will cover this during chapter 2 when we talk about software, because that is when we will really have to pay attention to this directory and then use tree to display its contents. So var lib contains dynamic data libraries and files and state information pertaining to application or to the system itself. And the state information is data that programs will modify when they run that pertains to one specific host. And so you preserve state information in this directory here. For example, we will be looking at this file, and this preserves the leases that different devices have on a pool of IP addresses as dispensed by dynamic host configuration protocol, which we will be setting up in chapter 6. So if you look at these, I don't have DHCP set up right now, but it would be here, and I would look at it for it in this directory. And that's the point. I want to show you where all of your files will be if you need to find them. And this will help also if you're using the find command, because if you know that it's going to be static information about an application, you can just start here and then use the find command to find what you need in the directories, or the tree command, or whatever you would like to use. And so, yeah, as long as you have the road, the landmarks actually mapped out. Now, let me move on to another very interesting directory. The var log directory is where system and service logs are kept. And so, of course, you would look in here for your error messages when something goes wrong. And now the wtemp file is a log of all successful logins, and then the btemp is a log of attempted bad logins, and then utemp is a log of active logins. So let me just, so the information in the utemp file is displayed. Let me just clear the screen using the w command that shows your users and what they are doing. The who command that shows who is logged in, and then the users command that shows, the usernames of users currently logged in. Okay. So just to a little demonstration about that. Now, this is where system logs are kept. And the var log messages. And then this is where logs related to authentication are kept. So every time a user attempts to use substitute user, or sudo, there will be a log entry. However, when someone uses su, there is an entry that shows that the user logged in, but there will not be an entry that describes what the user did when they logged in. So that's why most people like to use sudo, because this does leave a trail of evidence that tells people what you did when you used sudo. But I think that would be in chapter 2 or something like that. That I will go into further detail. Now, the mail log contains the mail server logs. I don't have so many mail logs actually. The last log command will report the most recent login of all users. And so it uses this file to, so this application reads this file to which documents every user's last login. And so this file documents the status of package installations. So I mean, there's a lot going on in var log here. I could go on and on. So this is for the error log and access logs if we had the Apache server running. Let me clear the screen. And so the spool directory holds spool files to store data so that jobs can be processed in sequence. And for example, spool files for mail and print jobs are kept in the respective directories. So moving on, actually, this is the directory that I would go to if I had a DNS, domain name server running. But of course, I don't have this working. And this is supposed to be the document root for our website hosted by Apache. But of course, it doesn't exist. But that is the default directory for a website. And let me move on to var run. And it contains process identification files and process IDs of system services. For example, var run utemp contains information about users currently logged in. And var run is symbolically linked to run. And then finally, Sysroot is a special root directory that contains a minimal file system and is often used when someone resets the root password for their system. And then the MISC directory is a temporary directory used by AutoFS to automatically mount devices and volumes. So later on, I think in chapter 4, we will be automatically mounting devices and volumes. So I hope you like that video that I've made. I just went exhaustively through the file system. I'll just let the credits roll actually on my references here that I have used. And I just wanted to tell you that the find command that we will use later and the ls command and other commands are very good at their jobs. However, before that, you need to know the major landmarks to search for. So, for example, if you know that you're looking for a configuration file for your application that you have installed, then you would use the USR general directory, and then find would have a better time of finding exactly what you were looking for. And so if you needed to look for a user file, you would look in this directory, and you would not have to start at the root directory, because that would overtax your system. And so the better you know your file system, the faster your searches for files will be. So I hope you liked this video, and catch me on the next one, and have a great day. Thank you.